1.1 squared is 1.21, but 1 squared is only 1.
Okay. All right. So let's find the slope between 1.1 and, or between these 2 points. So if we go 1.21 minus 1 over 1.1 minus 1, we get 0.21 over 0.1, which is 2.1, which isn't really close to 3. So we got a lot closer to this, which would probably be a lot closer to the slope there. But let's get even closer yet. Let's go from 1, to 1.001. Whoops. So what's 1.001 squared? 1.002001, I think. So it's 1.002001 minus 1 over 1.001 minus 1, which is 0.002001 over 0.001. So if we divide that, we get 2.001. Okay, what's happening here? Well, my x values are getting closer and closer to... No, my x values went from 2 to 1.1 to 1.001. They're getting closer to 1. Like a what? Like a limit. So we're kind of finding a limit as x approaches 1. What is my y value approach? What do I get with my slope? I was at 3, and then I was at 2.1. Now I'm at 2.001. I'm really getting close to 2. Okay, so the slope of this curve at the point 1, 1 equals 2. Okay, let's find the slope at the point 2, 4. Well, from 2, 4, I can go up to 3, 9, right? And find the slope. 9 minus 4 over 3 minus 2 is 5 over 1. So the slope is somewhere around 5. But we found last time that it wasn't really that close to that first number we found. So if we go 2.1 or 2 from 2.4 to 2.1, what's 2.1 squared? Is that like 4.41? I don't know what it is.
I also don't know what it is.
4.41? Okay. So now if we find the slope, 4.41 minus 4 over 2.1 minus 2 is 0.41 over 0.1, which is like 4.1. What do you think that it's going to on this? It went from 5 to 4.1. If we go down the same amount, again, we'll be down to 4.01. So it's going to 4. So the slope at this is 2. The slope of this is even greater than that. That's like at 4. At 3, 9, what do you think the slope will be at? And you are correct. It is 6. Okay? So what's happening? Well, my slope is 2 times the x value. My slope for this function equals 2 times the x value. Okay? So we are able to find the slope of a curve using this information. Now, what if I get an equation like this? Y equals x to the 5th minus 3x to the 4th plus 2x to the 3rd minus 7x squared plus 5x minus 2. That would be rather hard using our process we just used to find the slope of a point. Okay? So what we'll be learning this chapter is how to find derivatives and then plugging points into the derivatives to find the slope of a curve. So what are we doing at the start here? Well, at the start, we're just working with rates of change. Okay, to find the rate of change, let's say my function is f of x equals 3x plus 5. Okay, I want to find the rate of change from 2 to 5. Okay, to find a rate of change, you take f of b minus f of a over b minus a. Okay, where this is a and this is b. Okay, so how do I find my rate of change from 2 to 5 for that function? Well, you stick in your b into the f of x. What's 3 times 5? Plus 5 is 20. What's 3 times 2? 6. Plus 5 is 11 over 5 minus 2, which gives you 9 over 3, which gives you 3. The average rate of change is 3. Okay? What do you think the average rate of change will be for the same function from 8 to 11? Well, let's just see. What is 3 times 11? Plus 5 is 38. Minus, what is 3 times 8? 24 plus 5 is 29 over 11 minus 8. Well, that gives us 9 over 3, which is 3. My average rate of change for this is also called my slope. When I have a linear function, my slope is my average rate of change. Now, not everything is going to be a linear function on your homework. So you're just going to have to basically use this formula to find average rate of change. Okay? What else do I want to talk about? Come on. There you are. Okay. The derivative of a function gives the slope of the function at that point. So, if I have the function f of x equals 2x plus 4, and I want to find the first derivative at 1, well, in this function, okay, dang it, x squared plus 4, okay, if I want to find the slope of that function, I have to work with its first derivative. And let me go back to this one more time. Would you open up, please? There you go. So on today's homework, you'll be looking at a function and you'll be estimating what the first derivative is. Okay, so you'll be estimating the slope of the function. So if we have x squared plus 4 x squared plus 4 is like a parabola. It goes up like this at 1, and this is a bad representation. That's a bad representation. At 1, what does it look like the slope is at? Well, if you draw a tangent line, it looks like the slope is 2. Okay, so you'll be doing a little bit of that. Watch some of the videos, and he'll kind of clue you in on what?
How many assignments do we have? Like 2? 1 maybe?
What I'll do, Megan.
It was worth a shot.
What we'll do is we'll just go boom, boom. We'll stop at 7, and we'll save the other ones for later. It's not even a whole section like I usually do.